So now it is working. Let's start today. Okay, we don't need link. So this is the question based on like two pointer container with most water. So what happens is you are given an array and each index of those array is representing the height of, let's say, height of blockades. So vertical lines, height of vertical lines. So this is the height of 1, and this is a height of 8, and eventually this is a height of 6, 2 and 5. You have to tell me like what is the maximum amount of water, maximum whatever unit of water that you can store between these two lines. That is the question. How we are calculating? So maximum, let's say maximum, let's say volume of
You are
water.
recording,
So
right? Like, just ask.
yeah, yeah, I am recording.
Okay.
Recording is on. Yeah. So let's say what is the maximum water that we can store between any of these two poles, vertical lines, and we have to maximize that water holding capacity of this. So let's say this is of length 6. Let me change the color. This is of length 6, this particular pole, and let's say if I want to store water between this and this pole, so what will be the water, what will be the, like, let's say, the amount of water that will store? So minimum
Is
of
the
both of these two poles,
hmm.
this is 6, this is 8, 6, and multiply, you will multiply with the unit of base that you have. Okay, so this is, let's say, 0, 1, 2. So 2 minus 1, that is 1 index. So let's say you are storing a 6 unit water. Let's say the unit is not given, 6 unit water. But let's say if you are trying to store water between this pole and this pole, between this pole, so this has a length of, let's say, 5, and the area is, let's say, 0, 1, 2, 3, 4. So 4 minus 1, that is 3. So 5 into 3 will be the area. So you are storing 15 unit. Okay, so this is also an answer, and this is also an answer. But what answer that I have to select? You have to select answer which is storing more and more water, the maximum water that someone is storing. So that is the thing. So let's say the given array is nothing but 186, 186, and then I have 2, 5, 4, 8, 3 and 7. So these are nothing but these are representing the height of a vertical lines, height of poles, and between any of these two poles you can store water. Let me also write the indexes of these as well. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So now tell me two, three things. Let's say this is of height 1 and this is of height 2. Till what height you can store water?
One.
1. It is like a general intelligence, simple thing, because if you are going beyond this, the water will flow out here. Simple. So we are always considering the minimum of both of these two poles. Whatever poles we have, we are considering the minimum of both of those two poles. And then what we are doing, whatever the indexes of those two poles are, we are trying to find the length of these things. So we have got height, and then we have got length. So we can simply do length into height. That will give us an area. So what is the maximum area between those two poles? Okay, started on Zoom, started on Meet. I thought I do it on Zoom, but let's see. We've just started. So we'll take the minimum of whatever poles we have, and then we multiply it with the area. How you are going to find the area? This is, let's
Um,
say, L. This is R. This is L pointer. This is R pointer.
I think we need to do L minus R, right? That is one thing, and height H
0 minus 1 will give you a minus 1. You'll always have to decrement from
mod
higher to
mod.
lower. So R
Yeah,
minus L. Okay, mod we can do. That is also fine.
and we need to take the height, least height.
and whatever r minus l you have got, you'll have to multiply minimum of what?
Height.
Height of L at L pointer, and whatever minimum of height of R pointer.
Hmm.
So let's say min height multiply by R minus L. Till here
Ah,
it is clear.
yes.
So how this is a two pointer question, and how you will move your pointer is a question. Okay, that is also a question. So let's see how we are going to do it, and why we are incrementing, how, like, what is the intuition behind why two pointer will work here, why L and R will work here. These are some questions that will answer in this particular stuff. So let's say you're at this point, you are at this 1 and you are at this point 7. uh, you'll take minimum from 1 and 7, from pole of length 1 and from a pole of length 7. What minimum height you will take, what height you will take?
1.
So let's say, let me write this height, and we have let's say length, and then we have got area. So we'll try to maximize it. So the height that will take will 1, the length that you will take,
0 minus
this is, let's say
8.
L, this is R, that will be R minus L, simple 8. Okay, so what will be the area?
8.
8. Now here is the question. Okay, which pointer you will move? Will you move your L pointer, or you will move your decrement your R pointer, or you will increment your L pointer, and why? Do you have any answer, like you want to attempt this?
Mm. First, we need to do both, I feel. So once I will decrease L, we'll see the area, max area.
Mm-hmm.
And if we'll keep L as constant, decrease Y, R, we'll see the max area. Whichever the area is max, we will go in that direction.
So
That
at this
point I will
particular
go.
index, at this particular time, when you have L and R and you have calculated your area, so this is the area that you have got.
Hmm.
Now, what pointer you are thinking of moving? Whether you will
6.
increment L or decrement R? What you
Okay,
are
let
thinking?
me first increment L and
Okay,
calculate the area. If the area is greater than 8, then we will be taking that L
okay,
constant.
fine.
If
Okay,
we are going to next, we will be decreasing the R next iteration. If the
mm-hmm.
area is we need to calculate the area. If the area is more, if the area is less, then we need to decrease the R pointer.
Okay. So first you have incremented your L, and then if you, while incrementing L, what you are doing, you have calculated, and then again you replace your L backward, and then you have incremented your R, and then again you
Yes.
have calculated for this pointer.
Yeah,
Hmm.
that is how we can do.
Okay, okay, okay. I'll give a simpler approach to this.
Because I don't
What
think so
is,
we can sort the array because it's two
hmm,
points are generally sorted, but
the
we can't.
length will be distorted then if you
Correct,
short the
correct.
array.
That's what we
Okay,
can't
we
sort.
cannot short it. So let's say we have got 1, and then we have got 7. We have got 7 here. So we have got 1, and then we took a minimum of this both length, so that we took 1. There might be another index. There might be a possibility of another index or another pole of length that is greater than this 1, and that is also greater than this 7 or less than 7. So there might be of length 4, there might be of length 6. Is it correct? That has higher parity than this one, and that can give you a larger area in terms of height. Although width will decrement, but the height parity is more, because 6 into 7 we are doing, like 6 into 6 we are doing, and then the length is always constant of 1 unit. So length will not have that much effect compared to the height. Height will grow your area exponentially. So if you take 1 and then you move your low pointer ahead, there might be a possibility that you get 4, there might be a possibility that you get 6. Okay, because we
Hmm.
have taken the minimum one. But if you have taken 7, and with respect to that 7 you have taken 1, and you keep your pointer fixed at 1, whatever greater indexes you get here, that will not have any effect because you will always take this minimum 1. Is it
Mm,
like clear?
no, it's not little bit not clear. So you
Okay.
are asking me that since it is an one,
Hmm.
right? That's the reason we are keeping this as fixed and moving it because that's the minimum. But
When
my concern is that
what
if instead of nine, if it is an eight, then
186. Okay, give me a test case where you think this will fail. I'll try run it on that. Do you have anything in mind?
yeah, instead of one, just interchange one and eight.
Okay, we have 8 and then we have 1 and then we
Uh,
have what? 6,
same, whatever, huh?
2,
Same thing.
5, 4. Again we have got 8. We have
Hmm.
got 8. So we have got this 8 and this 8. Now let's
Now the
take this
area
as
is
let's say 2. If we are equal, then we'll have to increment both. So one is greater, one is smaller. So we have taken this 8 and this 2. Okay.
hmm.
Now what you are thinking?
Now I can't keep as L as fixed, no, because as per the theory, like if I will keep, I can't move that L. L means eight pointer one. I don't want
I
to move it.
cannot move.
Correct.
Fine.
I need to move two to more because obviously there is a chance of higher value of two because it's a lower value,
Yes. So
right?
we have got 2. We have got 2. So in 8 and 2, we have taken this 2. But there might be a possibility that we get 4. So if we have 4, we'll discard this 2 and we'll take this 4.
Yeah,
4
correct.
is greater than this 2.
Another
That
can
is
be
what I'm saying.
possible that instead of two, if that is six, let's
If
interchange the
let's say
value
that
of
is
six
6.
and two. Six and two interchange the value.
Here.
Last point, put that six,
Okay. Let me just put this 6. 6.
and in that 816, keep that two or something, whatever.
Let's take it as 1.
One or two, whatever.
Okay. 2.
Now, six and eight, that is the max value, right?
Okay. Fine. 8 and 6 max is value. Let's say
So
uh,
that means the
6
output is the
multiply by
max.
whatever the area x, 6x is there. Okay.
Now, if I will reduce that six, since eight and six, six is smaller, we will be reducing
Yes.
six. Now it will go back to four. It is not going to
4.
take because it's less. Then it will
It
go
is
back to
less. Yes.
five, five, two, everything
No,
until
no, no,
another.
no. You will take 4. You will take 4. You will calculate area. If your area is greater than this 6 na, only then you will decrement or you will increment. Okay, let me tell you like how we are going to proceed. I'll tell you complete process and then we'll discuss what is the problem and what is
Mhm.
it. So let's say we have some numbers. What was the numbers here? Wait a second. 186254, smaller number. So 1862 5 and 4. We'll keep one pointer here. We'll keep a one pointer here, lower and higher. And once we are, let's say, in, we'll simply say while less than equals to high, whatever iteration you do in two pointers, whatever. We'll calculate area and we'll take one area, like one, let's say, answer. We'll maintain a global answer where we are storing our max area stuff there. So we'll calculate area. How we are going to calculate area?
Uh,
Whatever minimum of L and R you have, and you will multiply with R minus L that we have discussed. है ना? Because we are taking minimum of 1 and 4. Whatever it is, we'll taking the lesser wala pole. So you will simply do what is my minimum of height on L side and height on R side. I'll take that minimum, and whatever minimum I have got, I'll simply multiply by R minus L. Till here it is correct.
yes.
Here till here it is correct. Then how we are going to do? We will check one if condition. If my height, whatever h of, let's say, if your height of L is less than your height of R, if this is the case, L is less than height of R, so you will simply increment your L. Else means R is L is less than R, means R is less than L. In else case, you will decrement your R. This is the thing. Now tell me what do you think where it will fail. So what I'm saying, okay, if we have got 1 and 4, what I'll do, I'll calculate its area. So let's say 0, 1, 2, 3, 4 and 5. So I have calculated this area as 1, 4 and 1. So I'll take 1 into 5. So I have got 5. So my answer initially is 5. Then what I said, okay, this is smaller than this 4. Now move your L pointer to next pointer 8. And now calculate the area. What will be my area? So in terms of 8 and 4, what will you take? You will take 4. You will take 4. Like, you
Yes,
understanding or
no,
not?
yes, yes. Then we will be decreasing 4 to 5. We'll go there.
Okay, no. Let's calculate the area.
Okay,
Let's
yeah,
write on this. So okay, 5 minus 1, that will be 4. So the area is 16. Now you will
correct.
update, because the previous area that you had got was 5, but now you have got what? You have got 16. So you will update your answer with 16. Now my
Yes.
current area is 16. Now I have got 4. 4 is smaller than this 8. What I'll do? Okay, I'll move my high pointer to here. Now I have got 8 and 5. So what height you will take? You will take 5.
Yeah.
And then 4 minus 1, that will be 3.
Yeah.
That is
15.
what? 15. Will you update your area? Because
No.
the previous area that you have, maximum area that till
No,
then
we'll not
you have
update.
got is
Yeah.
16. So you will not update. So which one is smaller from 8 and 5?
Then we'll move the 5 pointer to 2.
Yes, we'll move to here. Now let's see what is the minimum height that you will take. 2. Because if you take 8, you will not fill, you will not be able to fill that bucket beyond 2. So
Yeah.
we are taking 2. Then let's say 2 multiplied by 3 minus 1, R minus L we are doing. So if this is R, so R minus L 2, 2. So the area you have got is 4. Will you update this 16 with 4?
No.
No. Then again you will move your R pointer, because R is smaller. So we are moving my R pointer. So now what is the minimum area? What is the minimum height we have got? 6. And we'll multiply 2 minus 1. 2 minus 1 is 1. The area we have got 6. Will you update your 6? No. 16 is my maximum area that we have got. Why this is working is a question. Why this is working? Okay. 186254. 186255 and 4. Okay. So let's say you have taken 1 and then you have taken 4. So let's say this is the one pole, this is the four length pole. Okay. Then you have calculated an area of this. So you have the minimum that you have taken, the minimum one that you have taken. There might be a possibility, there might be a possibility that we might have of 6 length, we might have a pole that is beyond 1, which is of length 6. If this is of length 6 and you take minimum of both of these two, you think like you are taking the maximum. Like your initial threshold was 1, but now because it is somewhat equals to this higher pole, H and L pole, now you can take less than equals to this L pole, because the L pole is of length 6.
Correct.
Why this is working? Okay, let me frame this in another way around. क्यों ये काम कर रहा है? Okay, so ये अगर मेरा length 1 है, ठीक है, ये मेरा अगर length 1 है और इसके आगे मेरे को length 6 मिलता है, so पहले मेरे पास restrictions थी कि I can only take 1, I cannot fill this beyond 1. बट अगर मेरे को इसके आगे 6 मिलता है, अगर मेरे को इसके आगे 6 मिलता है, सो आई हैव दिस एबिलिटी, क्योंकि मेरे पास ऑलरेडी इधर 6 है, सो आई कैन फिल दिस होल टैंक. What if you move, okay, what if you move your high pointer? What will happen if you move our high pointer? So let's say अगर मैं इस पोल 1 पे हूँ and I have got this 8 length का, मैं क्या ले रहा हूँ? My base is 1, मतलब अभी तो मैं height 1 ले रहा हूँ, okay. Even if you got 16, even if you got a height of 16 by moving 8 high pointer,
It doesn't make
high
sense.
pointer, even
कुछ भी नहीं
doesn't
होगा.
make any sense, क्योंकि मेरे को 1 ही लेना पड़ेगा, क्योंकि I am taking minimum. So जो मेरा हिंडर कर रहा है, जो that whatever the restriction is, why not to explore that options? Why we are not exploring that options? So अगर ये मेरा 1 मेरा restriction दे रहा है, if I got anything for 4, that is a plus point ना, ये मेरा plus point है.
Got it.
आप
I
समझ
got
रहे हो?
your answer. हाँ.
Okay, why like अगर ये मेरा 8 है, so ये मेरा plus point है. Even if I got 16 here, I can make my answer with 8. But अगर मैं 8 को ही move कर देता, तो अगर मैं 1 को फिक्स रखता तो I always have to take 1. That will not give my optimal answer. So that is why we are always fixing our higher length. That is the intuition. Why we are fixing our bigger length? Because by fixing bigger length, if we get anything that is greater than our lower length, okay, that is anything that is greater than our lower length, we can make a larger answer with that, है ना. 1 के साथ तो हमेशा आप 1 into ये लेंथ ही करोगे ना. But if you have got 4 and 4 into some length you are doing, so that is an exponential growth.
Yeah.
Like 4 into some x आप कर रहे हो, something like that. So is it clear to you, like why we are fixing
Yes,
one
yes,
pointer, why
yes.
we are not fixing? Okay, I hope it is clear. So I'll simply show you the code how this is happening. I guess where we are container most water. So today I have done this in Java as well. मैंने पहले ही करके रखा है, so that we can cover more questions. So what is happening here? What is happening here? We have declared an answer variable that will store our maximum answer. We have initialized our low pointer to 0 and our high pointer to height dot length minus 1. Then simple एक loop लिया हमने. While low is less than equals to r, जैसा हम लोग लेते हैं normal like 2 pointers में. Then here what I am doing कि मेरे L and R में से मेरा कौन सा है minimum, that we have discussed कि we'll always take minimum. Whatever minimum we'll get will multiply with r minus L.
Yeah.
ठीक है, यहाँ तक I think it is clear.
Yes.
And then once we have got r minus L, what we'll do, whatever max value, whatever मेरे आंसर में पहले था, उसको कंपेयर करो एरिया से, और इन दोनों का जो मैक्स वैल्यू है उसको डाल दो मेरे आंसर में.
Got it.
You are understanding this line, na? Line number 8.
Yes, yes, I understood. No problem.
Okay, fine. Then what we are doing कि if my height is less than, मतलब height of lower is less than my height of the right one, मतलब height of left is smaller than height of right. What we are doing कि मैं बोल रहा हूँ कि ठीक है मेरा लोअर है, ये तो मेरे को हमेशा छोटा एरिया देगा, लेट्स एक्सप्लोर अ बिगर हाइट. वी माइट गेट समवट क्लोज टू आर वाले हाइट के, मतलब राइट वाले साइड के हाइट के मेरे को समवट क्लोज मिल सकता है. सो लेट्स एक्सप्लोर दैट पर्टिकुलर पोर्शन एज वेल.
Yeah.
And else if this is not true, so we'll decrement r, and that is what is happening. And pata hai, like what if you get 8 and 8? What if you get 8 and 8? You might think कि what if both are equal? I thought कि हाँ क्या होगा इस केस में, what will happen with if we get both the pointer 8 and 8? You will think कि okay, let's decrement it simultaneously. So let's do L plus plus and R minus minus. That will work. That will simply work. But that will also be managed with this if else. Why? Let's say you have got a pole of length 8 and again you have got a pole of length 8. So if you move your L pointer in this case, let's say if you move your pointer L, you got 16, but 16 is of no use because we are taking minimum. So still you will be taking 8. Even if you get anything that is smaller, so not 16, let's say 7. So if you got 7, so yes, we'll take minimum of 7. So that equal to wala case be managed with this if else loop.
So in this situation, the equals to all case is not handled, no?
Equal to wala case will not create any problem. It is handled in this loop. That is what I said now. Okay, let's say we have a length of pole of length 8.
Okay.
And again we have a length of
okay. No,
pole
that
of length 8.
I understood. But if it is the same, then we need to increase it as well as r plus plus, r minus minus, right? So in this loop, first it will decrease r and then it will increase l, something like that. It will happen. It will not happen in the same.
It will, let's say it decremented r and you have got something like 16.
Then only like it will be handled.
It does not have any effect.
Next iteration.
It will be handled in next iteration. Yes, that is what I'm saying.
That's what I mean to say.
So the maximum difficulty purely based on 2-pointer stuff that you will get is this problem. Okay.
Or
this is the like maximum
something stock buy and sell.
No, that is greedy thing. Stock buy and sell is there. That will there is this 6 different problems of stock buy and sell.
Okay.
So that we do in greedy.
Okay. I thought we do 2-pointer. Okay.
That is like let's say greedy. There is this stock buy and sell 1 that we will be doing. Okay, we'll take that. If you want, we can add this in two pointer or searching sorting maybe.
No,
And there
that's
is
fine.
this
That's fine. But I'm just
stock 2, stock 3, stock 4, stock 5, stock 6 is there.
okay. Just do that.
So
Okay, means just cover for
okay,
me.
so all these things below whatever stock 2, 3, 4, 5, 6 is there, that is somewhat like a DP problem. So
Okay,
we'll use DP
okay,
to
okay.
solve that
Then it's
problem.
fine. Then it's fine.
Stock 1 is a simple greedy approach. So we simply maximize, minimize it. We can cover, no issue with that. So yeah, we are done with let's say we are done with the continued with most water. So let's discuss this approach. Spiral matrix. Have you done spiral matrix?
No
What is your thought on
matrix
that?
questions. I didn't do much. I haven't done.
I'll discuss. Like this is also really good problem. This is like one of the favorite problem for like for freshers. They ask a lot of these questions from freshers. I don't know, like from experience, even if we ask not, but this is a really good example. We'll be using let's say 4 different pointers. So 2 pointer में ये काफी extreme level problem है. So if you are able to understand this, I think your two pointer problem is sorted. So like, you have any idea like how we are going forward with this
Like
initiation
spiral
idea?
matrix means we need to print it spiral, right?
Hmm.
Means it will go from 1, 2, 3, 6, 9, 8, 7, 4, 5, like that, right?
So it will go this way, and then it will go in this way.
Hmm.
This will go this way, and this will go on top, and then this way, and then this way. This is in spiral, like they are forming in spiral.
The 2 pointer one means
Yeah. So
it's a 4 point
okay,
whatever. 4 pointer or 2 pointer. I'm just telling that it's a.
don't like I गलत लिख दिया मैंने. So let's say forget about 4 pointer, 3 pointer, 2 pointer, whatever it is. क्या लगता है आपको, like if you are in an interview, how will you attempt this problem? Like मैं समझना चाह रहा हूँ कि till now what you have understood.
Okay, so if that is the thing, then we'll take 2 pointer one I and j. It will start from 1 as 0 0 as I and 0 max like 3 2 as j. Correct. So
So you're saying कि I and j pointer will start from here.
no, I will be there and j will be 3.
Okay, j is here. Fine.
Yeah. So I will increase until it will reach to j. Until unless
J.
I equals to j. Once
Hmm.
I equals to j, then j will start decreasing by keeping I as fixed.
Okay. Okay. Fine.
So then
So I
again,
is here, and then we can come here. So j is
yeah,
here.
yeah. Now and I will be at mm, 3, right? Uh,
Okay.
what will happen then once that will be then I will start. Okay, so it will start.
Use as much pointer as you can, as much variable as in reference that you can. Don't restrict yourself with only 2 pointers. I'll only use I and j. You can use k, you can use l, you can use m, whatever it is, whatever you think that you can use.
Next again I will then see k equals to that j. That also we can do like I j k means 4 places, 4 pointers. Yeah.
Okay, fine. Finally, like we are reaching it close to a solution idea. So let's say
Okay.
we have
I j k
ijk
and l,
and l.
four
Let's say,
pointers.
let's take this as an L.
Uh,
Okay.
then once first I will take I and
Hmm.
we'll go till j until unless j it will be same as j, then it will print. Once I
We have
equals
got one,
to
two, three in answer.
then once I equals to j, then j will start increasing till it will go to l.
Then again we have got 3, 6,
9.
6, 9.
Hmm. Now once done, then once j equals to l, then l will start decreasing until it will reach to k.
Fine. So we have got 9, 8, 7. That's true. Fine.
Correct. Now the thing is, I need to go to k to 4 only, right?
I.
Hmm.
Yeah. So that will be, let's say, 4. And
Let's
then you will have to iterate in this way.
correct. Now I don't
So
know
that will
why.
be
How
fine.
will I go till 4 and 5?
Forget about it. Forget about it. So if you can think of printing this, we can simply put that in loop and loop will take care. Just like recursion take care of everything, loop will take care of everything. So let's take a bigger problem. Let's say 1, 2, 3, 4, 5. Let's say 6, 7, 8, 9, 3 to 5, 3 to 5, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. Okay, this is like
18, 19. It
intimate
will be.
string. Okay, 19. Like, that doesn't make any difference. We just have to print. We have to just print it. So let's take this as a right pointer. Let's take this as a left pointer. This will act as a reference. Let's take this as a top pointer. Let's take this as a bottom pointer. So, okay, let me decrement the size maybe a little bit. Okay, now this is fine. Okay, so, okay, so what we have to do first, we have to limit our pointers in the range of less than right less than equals to left, and we have to print everything that is in this top wala row. Is it correct?
Yes.
So let's think you have printed everything in the top wala row. So 1, 2, 3, 4, 5. We have printed this 4, 5. Now the top wala row wala stuff khatam. मतलब top का row का काम खत्म हो गया
Yes.
है ना. We have printed this. So you will increment your top row. Now your top row become like this. Now your top row is this.
Hmm.
Then once you have reached here, you will print this left wala stuff, this whole thing, everything that is there, from left to bottom. So you will be in the range of this. You will be in the range of this, left to bottom, and you will print everything that is in this index, except this 5. So whatever the top range is there, so you will print from 6 to 9. Is it correct?
Okay.
6, 7, you have printed 8 and 9. Once you are done this, what you will do? You will decrement your left pointer because this column we have printed. Once you are done with the column, you will decrement, you will increment. Now your left pointer is somewhat in your left pointer is pointing to this column. Okay, now what you have to do, this is your left pointer, you have to be in this range, and you have to print everything that this bottom is pointing to. So we will print 10, 11, 12, and 13. 10, 11, 12, and 13. I guess we are done with this bottom. As we discussed, once we are done with that row column, we increment or we decrement. So once we are done with the bottom, we know we have to go on top. So we'll eliminate this and we'll say, okay, let's go to top. So that will be your bottom. Now you have to be in this range and you have to print everything that this right is pointing to. This right wala column is pointing to. Your range is this bottom to top. Whatever right is pointing to, you have to print that. So you will print what? 14, 15, and 16. 14, 15, and 16. You have printed this whole stuff. So you have printed one in this. You have printed in this bottom. You have printed 14, 15, and 16. What do you think you will do with the right?
We'll increase
Once
it.
you are done with this, now your right is pointing to this thing. Again, whatever we have done, so we printed this, then we printed this, and then we printed till here. Whatever we have done here, Now what was my range initially for printing right to left? It was from here to here. Now your range decrement to from right to left, here to here. So you will print what? 17, 18 and 19.
Yes.
Like how we are playing with the range, how we are playing with the range, and you will print this top. So we are doing that same repetitive work, but my range changes. My whole range, like, it got changed. And also we are doing this in a cyclic order.
Correct.
What do you mean by that? What is cyclic? So, like, there is a lot of solution based on this. People are using while loop and if and else and a lot of thing. I'd like to do this in a most simpler fashion. So what I'll do, I'll point some numbers. Okay, let me tell you what I'll do. I'll do a really good stuff. So let's say you have a variable a that is 0. I'll say whenever you get a is equals to 0, you print this range. Okay. Whenever you get a is equals to 1, you print this range, this side wala range, left wala. Whenever you get a is equals to 2, you print this wala, this thing. Whenever you get a is equals to 3, you print this. Is it correct?
Yeah. One.
So if my a is 0, I'll simply run a loop for this right to left wala pointer. If my a is 1, I'll simply run a loop for this left to bottom. If my a is 2, I'll simply run a loop from this left to this bottom. If my a is 3, I'll simply run a loop from bottom to top. You simply think of printing this outer wala line. If you have understood this, think के ये वाला print हो जाएगा अपने आप. So we are framing our conditions in such a way that if you can print this outer loop, these things will automatically get printed. Because ये कुछ नहीं है, फिर ये 0 हो जाएगा, ये 1 हो जाएगा, ये 2 हो जाएगा, ये 3 होगा, फिर ये 0 होगा, and then you are done.
Okay.
Then you are done. What is my stopping criteria? Where will I stop? Is a question. Is a really good question. What do you think?
When a equals to when like all the pointers will be same, right?
Same. So a condition at this point, your right is less than equals to your left, your top is also less than equals to your bottom.
Correct.
So your right is less than equals to your left, and your top is also less than equals to your bottom. This is the condition when you know that you are pointing to one index, and
Correct.
this is your last index. And here, once you are done with this, you'll simply eliminate your while loop. Any doubt in this? Any pointer?
No.
Any doubt how you'll move on? Okay. How we are moving our pointer idea. Let me like write a code snippet, then I'll explain what is going on. So what I explained, okay, what is my okay, let's write all the boundary cases that we'll do, and then we'll wrap it under a while loop, so that it will simply repeat it till we have the indexes to print. So let's say first we discuss, okay, we'll go for right to left, right to left, we'll go right to left. What is the logic that you can think of to go to right to left? And I discussed, okay, if my a is equals to 0, in that case I'll run this loop. So if this is the thing, I'll simply run a loop for what? For int my I will point to what?
Unless this right
I think this
not
is right.
Okay.
This is left, na?
Okay.
This is right.
Okay. I equals to 0 to
I is equals to left, because left is your what is your range? What is your range that I'm asking? Your range is left to right. So you will iterate from left to right. So I is equals to left till my I is less than equals to
right. Yeah.
my right.
Correct. Right.
I'll do what? I'll do simple I plus plus. Inside, what I'll do, you will simply print, you will write a print statement. Okay, we are doing nothing, we are not worried about storing it at somewhere. We'll simply print it. So we'll print what? Matrix of what? This was the
Matrix of I comma 0.
I comma 0, but 0 is represented with what? What row number?
Right.
That top.
Okay, you are telling that A equals to
Okay, let me
0.
see. Okay, let me see. If you have to print this, what you will say?
0 0.
0 0, but 0 0 is point. We cannot hardcore ना, हम लोग hardcore नहीं कर सकते ना 0 0, but it
Yeah,
will,
yeah.
if you do a 0 0, it will not work for 0 1
Correct,
0 2. We have to make it a generic.
correct,
So do you think कि ये top भी यहाँ point कर रहा है, ये right वाला भी यहाँ point कर रहा है?
correct.
Can you see? और मैंने let's say sorry, ये तो left था actually, मैंने पहले ही गलत लिख दिया था, ये right होगा मेरा. So this left is also pointing to this top is also pointing to this. तो अगर मैं ऐसा कुछ कहूँ कि मेरा matrix of let fix this top, एंड मैंने लेफ्ट को किससे पॉइंट कराया है? आई से. रिमेंबर, आई विल चेंज. सो ये पहले यहाँ पे होगा, फिर ये यहाँ पे जाएगा आई, फिर ये यहाँ पे जाएगा टिल राइट तक. अग्री? सो डू यू थिंक कि अगर मैं इस लेफ्ट टू राइट इटरेट करूं और इस स्टेटमेंट को प्रिंट कराऊं, सो आई विल गेट 1 2 3 4 5.
Yeah.
व्हाई? बिकॉज मैंने इस रो को फिक्स किया है. ये रो इज पॉइंटिंग
Yes,
टू
yes.
द
Row is
जीरोथ रो,
fixed and I is column is.
and then we are iterating over I.
Yeah.
Okay, so this is what we are doing. So we'll print what?
Top.
Whatever your top is,
Top I.
and I. You're done.
Yeah.
But हम लोग कुछ काम भी कर रहे हैं. Remember कि once we are done with this row, we'll do what? Top को यहाँ से हटा के अगले रो पे पॉइंट करेंगे कि now your range is this.
Correct.
So top is next row. So once this loop will end, what you will do?
Then top plus plus.
Top plus plus. Simple. Top plus plus. Let's say we went to what? Left to right. Now my task is to go from
Right to bottom.
go from left.
Right.
My task is to go from here, ये वाला, ये top to bottom. We are iterating this ना.
That is fine, but also we need to do that vertically, na? That's the reason I told right to bottom. Okay.
That is the printing. I'm asking कि what is my range? What is
Okay.
my range? If your top is here, what is your range?
Okay. Range will
Your top is
be
here.
from
Top to bottom.
yeah, top to bottom. Yeah.
And for every index you will print right, and whatever top you have pointed,
Yes,
J or K,
yes.
whatever it is.
Correct.
है ना? So once we are done with this, we are printing what? Top to bottom वाला case. This is my top to bottom. What I'll say?
For J
For
something.
for int, let's say no, this is block scope na, so this will not have any effect. For int I is equals to whatever top you have, and I is less than equals to whatever bottom you are at, and you will do what? I plus plus. Is it correct till here?
Yeah.
You will print what? Matrix of
A matrix of I comma.
Because we have to change our row.
Correct.
And this represents row.
I comma
And
bottom.
this right.
Right. No, right or
No, not bottom. Let's see here. Bottom, top and bottom is what is
Fixed.
telling us the range, but this column is represented by a pointer right. Agree or not?
Yeah.
So if you have to print, this is what? If top is represented by I, so this is the ith row, but this is the right wala column. So column will be fixed.
Okay, I got it.
Right column will be fixed.
Right. Okay. Yeah.
Okay. So let's take this thing. Okay. Let's
Yeah, I
take
got
this
it.
thing.
Got it. I missed out. Yeah.
N and M, and we have to print this column.
Then
So
M.
here I is equals to 0.
Yeah.
I is equals to, let's say, N. So we'll do what? We'll keep on iterating on I, but we'll fix this M. Let's say if M is this J.
Right.
So we'll keep J, but this will increment after every iteration. So I plus plus, but J will be fixed.
Yes.
So J will always be this, but your I will change.
Yes,
So this
yes.
is what we are doing.
Correct.
So
correct.
top to bottom is my range. So I'm iterating on the for loop from top to bottom, but I'm keeping my column as fixed. So this will
Correct.
be printed.
Yeah.
So as discussed, mat of I and right we have printed, and then once we are done with that right wala column we have done, so we'll decrement this right. I think we
Correct.
discussed,
Right
no?
minus
So we'll
minus
decrement the range. So we'll do a right
minus.
minus. So
And
we have
bottom,
printed,
we
let's say,
have to give that bottom how much, what is the value of the bottom? We are keeping it here as the size of the matrix, right? Like, okay.
that will be size of the matrix.
So for that, is there any predefined function is there to get the size?
You'll have to calculate like predefined. There's no predefined. So let's say if this is the matrix, okay,
So again, I
for
need to.
top bottom for nm, how many rows are there?
So M, we need to take the bottom as M, right? N.
Let's say this is n and this is m. So m number of columns, n number of rows. So let's say you have given a matrix of, let's say, this. What you can do in order to get row, what you can do, you can simply say you can simply write mat dot length.
Okay, that's what I
Okay,
asked. Yeah, is there or not?
this will give you row.
Take.
And if you want to column, what you can do, you can write mat 0 dot length. What will this say?
Yeah,
Okay, ये
column.
एक पहले का ये लेंथ दे देगा, मतलब mat 0 represents what? First row.
Got it.
First row का length method. So this will give you a columns, total number of columns it has.
Yeah.
So that is how we are finding top, down, bottom, whatever it is.
Okay.
So we have printed our left to right, we have printed our top to bottom. Now let me tell you, can you print this? What is the range of this? Your right is pointing to this index, your left is pointing to this index.
Yeah.
Is it like
When right
to
is
left?
not equals to left, like right to left जाएगा.
Right
I
is
minus,
greater than equals to left is something what we can write.
I minus, yeah.
So we can simply write के एक for loop लो and I will my point to एक right, while my I is let's say greater than
Left
equals to left, and
minus.
I'll do I minus, and I can fix what? I can fix my bottom, because this is my row, bottom wala row है ना, and that is my row. So I'll simply write a print statement. तो मैं matrix में
Bottom,
I'll fix my
I.
bottom and whatever the I is there, so I can simply print I. So we have printed this. Now once you are done, you will do what? तुम बोलोगे bottom भाई तुम ऊपर चले जाओ, है? No, bottom minus.
हाँ, bottom minus.
तो bottom ऊपर लेके जाना है ना. So now bottom is this. So now your bottom is this, and top को तो हमने पहले ही reduce कर दिया था. तो now this is my range. तो where to where you have to go? You have to go from bottom to top. Bottom to top, fixing your left pointer. Okay. So now what you will write? You will write okay भाई एक काम करो, I जो है मेरा वो bottom है, and I जो है वो greater than equals to मेरे top तक जाएगा, और I मैं minus करूंगा क्योंकि मैं नीचे से ऊपर जा रहा हूँ. So I am 3 going to 2 going to 1 and something like that. Then what I'll say, let's keep the row fixed. Row is nothing but pointed by left pointer. So I'll say okay, whatever my matrix is, let's keep the row left fixed, and whatever the I value is changing, keep on changing. So we'll have our column that will be changing on each row. Is it correct?
Yes.
Row is changing na.
Row changing.
Row is changing. The column is fixed. Column is left. So we have printed. Once you are printed this thing, wrap this whole thing in a while loop till you meet this condition, and that will print everything. You don't have to worry about अब मैं कैसे करूँ इसको, अब मैं कैसे करूँ. Automatically होगा ना, automatically होगा. Once you have printed this, you will increment your left pointer. Now your left pointer is pointing to this index. Now your right pointer is pointing to this index. Again you will go in that same loop वाला condition. बस your range will change. Range change हो जाएगा.
Correct.
है ना? So now your range, initially your range was here to here. Okay, let me change a pen color. Initially your range was here to here, pura till 16. Now your range is this 17 to 19. Is it correct?
Yes. Now it will be.
Again that same for loop will work. Again this same for loop will work here. Again that same for loop will work here.
Okay.
Now tell me, any doubt?
No, it's fine. Got it.
So let me just explain the I guess implementation I did. Okay. Also, what happens is that the approach that I discuss, you have to manage few edge cases as well. Okay, what if you have only one row, है ना? What if you have only one row? तो आप तो लेफ्ट से राइट आ जाओगे इधर, है ना? एंड यू विल गो टॉप को नीचे कर दोगे, तो टॉप से बॉटम तो आपके पास कुछ है ही नहीं. बट व्हेन यू गो राइट टू लेफ्ट, सो व्हाट विल हैपन कि यू विल प्रिंट दिस, आप इसको ही प्रिंट कर दोगे एक कम करके, है ना?
करेक्ट.
मैट्रिक्स में क्या होता है, मैट्रिक्स में क्या होता है कि ये हमारे पास है, दिस इज ऑल एवरीथिंग दैट इज पॉइंटर. सो लेट्स से आपने यहाँ तक प्रिंट किया एंड आपने आर को इधर कर दिया, तो योर आर इज पॉइंटिंग टू दिस, बट योर टॉप इज पॉइंटिंग टू दिस इंडेक्स. बट होगा क्या, एट सम पॉइंट इफ यू हैव ओनली वन रो, तो आप इसी को रिवर्स में एक बार ऐसे प्रिंट करोगे, या फिर नीचे जाके इस वाले में एक कम करके इसको ऐसे प्रिंट कर दोगे, क्योंकि वो उसी को पॉइंट कर रहा होगा. तो ऐसा एक प्रॉब्लम आ सकता है. दैट इज वाई टू अवॉइड दैट प्रॉब्लम, मैंने ना एक इफ एल्स का लूप लगाया है कि अगर ये 0 है इसको प्रिंट करो, अगर ये 1 है, अगर ये 1 है तो अप से डाउन आओ, ऐसे आओ, अगर ये 2 है तो ऐसे जाओ, अगर ये 3 है तो ऐसे जाओ. तो इफ केस में जब भी वो घुसेगा, अगर उसको ए मिलेगा तो वो ए वाले को जाके ये 0 है. ओके, आई एम सॉरी. Okay, let's say let me explain this again. So let's say अगर मेरे पास सिर्फ एक रो है ना, so what happens कि अगर आप यहाँ से यहाँ तक जाते हो, and then because this right pointer that is it will point here, and what you'll go कि आप लेफ्ट से इधर आओगे, because your लेफ्ट से आप इस साइड आते हो एंड बॉटम को प्रिंट करते हुए आते हो, तो बॉटम भी आपका इसी को पॉइंट करेगा, तो आप इसको ही रिवर्स में एक इंडेक्स छोड़ के आप इसको ही रिवर्स में प्रिंट कर दोगे. दैट इज वन ऑफ द प्रॉब्लम. वो लोग नॉर्मली इफ एल्स लगाते हैं. मैं क्या बोल रहा हूँ कि यू नो व्हाट, अगर मैं सबकी टर्न डिसाइड कर देता हूँ. मैं ऐसे जाऊंगा जब मेरे पास 0 रहेगा, मैं ऐसे जाऊंगा जब मेरे पास 1 रहेगा, मैं ऐसे जाऊंगा जब मेरे पास 2 रहेगा, मैं ऐसे जाऊंगा जब मेरे पास 3 रहेगा. ठीक है. सो वंस आई गॉट 0, मैं ये वाला लूप चला दूंगा. जस्ट कौन सा लूप चलाना है उसमें डिस्टिंग्विश करने के लिए. व्हेन आई हैव 0 I'll loop this, when I have 1 I'll loop this, when I am 2 I'll loop this, when I am 3 I'll loop this. Simple. अब होगा कैसे? तो one thing that is clear कि first move तो मेरे को इस डायरेक्शन में जाना है. Agree or not?
Yes.
मैं 0 से इनिशियलाइज करूंगा. लेट्स से आई हैव a, मैं इसको 0 से इनिशियलाइज करूंगा. वंस आई एम डन विद दिस ना, मैं a को 1 कर दूंगा. अब वो नेक्स्ट इटरेशन में आएगा, उसको a1 मिलेगा, तो वो जाके इसको ऐसे प्रिंट कर देगा. वंस आई एम डन दिस, मैं a को ना अब 2 कर दूंगा. नेक्स्ट इटरेशन में आएगा, उसको a2 मिलेगा, वो जाएगा ऐसा प्रिंट कर देगा. ठीक है. मैं अब उसको 3 कर दिया, नेक्स्ट में गया वो ऐसे प्रिंट कर दिया. 3 के बाद फिर मैं नीचे जाके उसको 0 कर दूंगा. तो अगेन जब रेंज चेंज हो गई तो फिर वो आके इसको प्रिंट करेगा, फिर ऐसे 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 घूमता रहेगा. सो दिस इज जस्ट टू टेल कि कौन सा लूप चलाना है.
A value for whatever the matrix size, it will vary from 0 to 3, right?
0 to 3. It will simply tell you कि कौन सा लूप चलाना है, किस डायरेक्शन में प्रिंट करना है. सिंपल है ना, किस डायरेक्शन में प्रिंट करना है.
Yeah, got it.
If it is 0, this direction. If it is 1, this direction. If it is 2, this direction. If this is like most of the beginner जो मैंने देखा है मिडिल टाइम पे भी प्रॉब्लम यही होती थी कि how you will make sure कि ये किस डायरेक्शन में जाए. So what happens is कि वहाँ पे फिर इस केस के लिए एक if else लूप लगाते हैं, वहाँ पे कुछ ऐसा लेस देन इक्वल्स टू हो. मैं वो नहीं चाहता हूँ, क्योंकि कई टाइम वाइल इम्प्लीमेंटिंग इन इंटरव्यू और इन कॉन्टेस्ट वो वाले कंडीशंस भूल जाते हैं. बट इफ आई टेल यू कि ये ए वाले पॉइंटर्स रखो, यू विल कीप रिमेंबर, लाइक यू विल रिमेंबर दिस थिंग फॉर श्योर, कि आपको याद होगा कि अगर मेरे को ऐसे जाना है तो मैं 0 पे जाऊंगा, इसमें मैं 1 पे जाऊंगा, ऐसे जाऊंगा मैं 2 पे जाऊंगा, ऐसे जाऊंगा मैं 3 पे जाऊंगा. सो दैट इज व्हाट आई हैव डन हियर. मैंने बोला अच्छा ये वाइल लूप आप भूल जाओ एक सेकंड के लिए, मैं ये कंडीशन देख ही नहीं रहा. मैं बोला कि अगर मेरा a इज इक्वल्स टू 0 है, सो दीज कंडीशंस दैट वी हैव डिस्कस्ड, कि मैं लेफ्ट से राइट वाले पॉइंटर्स पे जाऊंगा, मैं लेफ्ट से राइट वाले पॉइंटर्स पे जाऊंगा, और मैंने अपना एक रिजल्ट मैट्रिक्स बना के रखा है. मैं उसमें यहाँ पे लिस्ट ऑफ इंटीजर्स है ना, ये मैंने बना के रखा है. आई विल कीप ऑन एडिंग दोज थिंग्स. मैंने यहाँ पे टॉप लिया है, सॉरी अप लिया है, दैट इज नथिंग बट अ टॉप. ये आपको टॉप को रिप्रेजेंट कर रहा है. सो यू विल इटरेट हियर, यू विल फिक्स दिस टॉप एंड यू विल प्रिंट, कीप ऑन प्रिंटिंग. एंड वंस यू आर डन, आपने आपको प्लस प्लस कर दिया, मतलब टॉप अब यहाँ आ गया. अब टॉप इसको रिप्रेजेंट कर रहा है, एंड देन हमने ए को भी 1 कर दिया, मतलब ये 0 वाला प्रिंट करके ए को 1 कर दिया। आप समझ रहे हो?
Yes, got it.
Then again we are going this way, this way, this way, this way. So any doubt in this, like?
No,
अच्छा,
no.
इस पूरे को रैप अप कर दिया हमने इस while loop के लिए कि while my left is less than equals to right and my up is less than equals to down, what I am doing, जब तक ये मेरा कंडीशन वैलिड रहेगा, मेरे पास एक वैलिड इंडेक्सेस रहेंगे, तब तक तुम उसके अंदर लूपिंग करते रहो टिल यू रीच दिस। बिकॉज अगर मेरे पास एक काफी बड़ा एरे है, लेट्स से इतना बड़ा एरे है, एंड व्हाट विल हैपन इफ आई हैव दीज थिंग्स, once you are done with this loop ना, आप यहाँ पे हो, so again your left and right pointer is not equal। आप देखो यहाँ पे डिस्टेंस है आपके लेफ्ट एंड राइट पॉइंटर से, लेफ्ट एंड राइट पॉइंटर्स तब इक्वल आएंगे जब आप इन सेम कॉलम एंड सेम रो में हो, जब आपके टॉप एंड लेफ्ट वाले भी इक्वल हो जाएंगे। सो दैट इज pointing to कि you have reached the center।
Got
So
it.
yeah, now tell me।
No, it's fine. I understood you.
Okay, अगर आपको ये कोड चाहिए तो I'll simply share this।
Yeah.
Okay, now we are done। let's see what else questions that we can do। ओके मैं सोच रहा था कि मैं ये डिस्कस करूंगा मूव जीरो, दिस इज एन इजी प्रॉब्लम। फिर मैंने सोचा कि आई थिंक आपको ये खुद करना चाहिए, बिकॉज जितने क्वेश्चंस हमने कर लिए हैं उनके बेसिस पे यू विल इजीली डू दिस, देयर इज
Yeah.
नो
What is that?
पॉइंट इन
Move
डिस्कसिंग
0
दिस।
to the end.
हाँ, so what is happening here कि given an integer array nums, move all zeros to the end while maintaining the relative order of the non-zero elements। So what happens is there okay, we have 0 1 0 3 and 12। So what you will have to do okay, you'll have to convert this to something like this 1 3 12 0 and 0। so relative order कैसे maintain हुआ, क्योंकि 1 पहले आया था तो यहाँ पे भी 1 पहले, and then 3 पहले आया तो 3 पहले, यहाँ पे 12 पहले आया था तो यहाँ पे भी 12 पहले है। आपका जो मैंने डे 1 में आई थिंक काउंट शॉर्ट बताया था, काउंट शॉर्ट विल नॉट वर्क
Yeah.
बिकॉज यहाँ पे अलग अलग नंबर्स हैं, that number can varies 10 to the power 4 times, है ना, 10 to the power 4 different numbers हो सकते हैं, that will not work। so what you will have to do, I'll just give you a small hint and I think you can do this question easily। 0 1 0 1 0 3 and 12। so let's say your left pointer is here, your
Yeah, and
right
right
pointer
pointer
is
is
here।
on 1, and we will see if swap between those two if it is 0
if this condition match, your L is 0 and your R is not
not equals
equals
to
to
0,
0,
then we'll swap it.
you'll simply swap।
And
this
next
is
one,
something
right?
that you
Next iterations, it will be 1 0 0 3 12. So since both the things are 0, so we will be incrementing the R1
hmm.
and
Okay,
by the
it is
L1.
up to you, think about it, put some stress on this। I
Yeah,
think this is a problem that you can easily do it, like
yeah,
I'm
yeah.
expecting this कि भाई
Yes,
आप कर
yes.
लोगे, आपके पास
Correct,
तो
correct.
you have everything now, because once you have understood that spiral wala question, once you have understood that spiral question, uh, that problem container with most water, I think this is nothing, this is a relatively easy problem।
Yeah.
now let's say we have this problem, okay, why is this happening, okay, we have this particular problem for some that you have just said ke this quality is clear, like the concept and everything is clear to you, uh,
Yeah.
okay, then the two questions that I have added is this one, okay, this is really interesting questions, so think about it, how will you do it, and
Rotate the array.
just give me a solution idea if you get, also see the constraints as well।
Once again,
Yeah,
input nums 1 2 3 4 5 6 7, k equals to 3. Output 5 6 7. Okay. It's 1 2 3 4. Okay. So अगर 4 से मैं घुमा दूँ 4 4 3 2 1, then I will do that 7 6 5, नेक्स्ट इंटाले घुमा देंगे तो yeah, I can tell one thing.
Okay.
So K is 3, na?
Let's say case 3. Yes.
Yeah. So what I will do is that I will rotate from, I will break the array 1, 2, 4, 4.
Okay.
Okay. So it will be 4, 3, 2, 1, and I will rotate 5, 6, 7. So it
So
will
this
be
will be
7,
4, 3, 2, 1, and this will be
7,
7, 6, and
6,
5.
5. Then I will rotate the full.
Yes. Okay. This is the concept. This is really easy problem. So 5, 6, 7, and then okay, if you rotate the full 5, 6, 7, 1, 2, 3, and 4. This is the thing. Okay. But can you? There is this small implementation uh, problem here. Like you will get an error on this. Although the logic is clear, the logic is 100% right.
Okay. Why?
This will work. But if you see the constraints, there is this thing that will give error in some particular case. That can you think of that particular edge case that it will fail?
Number length is 10 to the power 5.
It is not really. So time limit exceed is not the case. You will get something like let's say segmentation error, or yeah, segmentation error you will get.
Why?
Okay. Okay. So let me tell you what happened. Let's say if I have 1, 2, 3, and if I give you k is equals to 8, how you are going to do it? This is a edge case. Like this, they ask this question only because of this case. If the student can think of this particular case or not.
Okay.
If the length of the array is 3,
No, no.
n is equals to 3,
No,
and
then
k is
K
equals
should
to
be
8.
smaller, right? K should be smaller than.
No, it is not given. Look at it. Okay, that is the beauty of this problem. K can go from 0 less than equals to k less than equals to 10 ki power 5, and the nums dot length n can go from 1 less than n to less than equals to 10 ki power 5. Any combination of n and k can be given to you. It is not said ke अगर वैसा होता ना कि they could have said के note k will always be less than equals to n, और यहाँ पे ही उन्होंने लिख दिया होता. But they have not mentioned it. Means यहाँ पे लोचा है. ये एक केस आएगा. ये एक केस आएगा. How like yes, how you are going to deal with this case?
Okay, if that is
Let's say this is 4 and 5. This is of 5 length.
then need to place whatever K is because need to place 0 for that, right?
Okay, 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 okay.
Or need to
So let's say
blank.
1, 2, 3, 4, and 5. I have to rotate this 8 times. Okay, 8 times. So like what will happen if I rotate this 1 times? This will be something like 5, 1, 2, 3, and 4, something like this.
Yeah, we are is asking for shifting.
You did one shift. You did one shift. If we did one shift on this array, तो मैंने 5 को उठा के आगे लेके आ गया मैं.
हाँ.
ठीक है. Again you did another shift. So this is shift 1. This is shift 2. If you do 2 shift, that will be nothing but 4, 5, 1, 2, 3.
Yes.
If you do 3 shift, that will be what? 3, 4, 5, 1, 2.
Hmm.
If you do fourth shift, that will be what? 2, 3, 4, 5, 1.
Yeah.
If you do fifth shift, that is what? 1, 2, 3, 4, 5. Is there any similarities between this and this?
Yeah.
कि ये और ये सेम हो गया. So आपको जो k greater मिलेगा ना, when you have k that is greater than n, आप क्या करना, k that will be equals to k modulo उसका n ले लेना, और इसकी जो रिमाइंडर आएगी ना k की वैल्यू, that is the actual rotations that you have to do. So अगर आपको 8 करना था तो 5 टाइम में तो again you have got 1, 2, 3, 4, 5, 4, 5 एंड 3 टाइम्स एक्स्ट्रा बचा, तो आपको ये 3 उठा के लाने थे, तो यही तो आपका एक्चुअल तो 3 3 4 5 1 2 होगा.
yes.
So
Right,
why
got
you are doing 8 times? क्योंकि n टाइम्स में जैसा एरे था वैसा आपको वापस मिल जाएगा, है ना. You will get the same exact array in n times, and beyond n times whatever you are doing, you are changing that. So
So if
beyond
I
n times
take
3,
the modular difference, so 3 means मतलब last से 3, fast से 3.
last से 3.
Okay.
We are always picking from last. We are always picking from last.
Okay.
मैंने जो 5 टाइम्स करा था, so 1 2 3 4 5, मैं 5 को उठा के लेके आया था इधर. So this was like 1 5 1 2 3 and 4, है ना. देन मैं 4 से लेके आया था, तो 4 5 1 2 3, और ये जब मैंने 5 टाइम लाइक 5 टाइम्स मैंने रिपीट करा, सो ये फिर से 1 2 3 4 5 हो गया.
Got it.
ये और ये सेम हो गया. तो आप n टाइम्स एक चीज को ही रिपीट करोगे ना, उसके पीछे के एलिमेंट्स को लाके. अब सिंपल से
I
थिंकिंग
got
है
it.
कि
I
ये
got
n
it.
टाइम्स है,
I understood.
है
Understood.
ना. सो इफ k इज इक्वल्स टू 8, अगर 8 है तो इसमें से n हटा दो, आप n हटा दो, क्योंकि n का कोई सिग्निफिकेंस नहीं है.
Mm-hmm.
बियॉन्ड मॉडुलो n जितने एलिमेंट्स बचते हैं, 3 जो बचते हैं, आप वो 3 टाइम्स रोटेट कर दो. दैट इज द थिंग. सो आप इसको करके देखना एक बार. आई थिंक दिस इज वन ऑफ द इजीएस्ट प्रॉब्लम.
Yeah, sure.
मैं इस पे आई थिंक एक और सोच रहा, ऑल्दो आई थिंक दिस इज अ मीडियम प्रॉब्लम, क्योंकि अगर आपको ये k वाला लॉजिक नहीं पता, यू विल नॉट बी एबल टू डू दिस. दैट इज अ
Correct.
एज केस. दैट इज व्हाई दे सेड कि हाँ ये
Correct.
ये मीडियम है.
I was not aware of this edge का. Yeah.
हाँ हाँ, when you have k greater than. So let's say मैं इसको एक दूसरे अप्रोच से बताना चाह रहा था आपको. So 1 2 3 4 5 6 7, let's say this is the case. Okay, we have 3. So एक मैं n-1 पे डालूंगा और उसके n-2 मतलब यहाँ पे पॉइंट करूंगा, और मेरा ये l and r है, मैं इसको एक फंक्शन में डालूंगा जो इसको रिवर्स कर देगा. सो आफ्टर रिवर्सल मतलब ये पॉइंटर को स्वैपिंग कर देगा, वो स्वैप कर देगा, मतलब लेफ्ट राइट को स्वैप कर देगा टिल लेफ्ट लेस देन इक्वल्स टू r. आफ्टर रिवर्सल दिस विल बी
765 हो
लाइक
जाएगा.
1 2 3 4 7 6 5 हो जाएगा.
Okay.
And if you reverse this whole thing, 5 6 7 and 1 2 3 4, is it the thing?
Okay.
नहीं, 5 6 7 4 3 2 1 होगा, and then you have to reverse this part. Okay, this is near about same.
Like
Near about same है, वो जो आप कर रहे हो वही है ये भी.
yeah, it's the same. Doing it fast, I am doing it second. Yeah.
हाँ हाँ हाँ,
एक
मतलब
ही बात.
फर्स्ट कर लो बाद कर लो, that is same.
एक
That is
बात
same.
हुआ. हाँ.
So I think we'll wrap up today at this, and I think rotate array and move zeros is somewhat like I'm supposed, yeah, like you are supposed to do that thing on your own. आप मतलब
Yeah.
खुद से try करोगे. Then I have another question, that is this next permutation that I'll discuss like next day. This is not basically depends. It is not exactly a 2-pointer question, but although I think I have added this question in the sheet. Sometime what happens ke interviewer ask ke implement next permutation. So you need to know कि अगर if I have given 1 2 3, what will be my next permutation, next greater permutation that will be there. So we'll do it in next class maybe.
Okay.
Okay, I'll stop the recording.
Yeah, and please send me the